Now that we have seen the algorithm behind selection sort and we have also written the pseudocode for implementing selection sort, right? Let's go ahead and implement the same thing using Java. For that, in the sorting package that I have created, I'm going to create a new class. Class name is selection sort. Let me have the main method in the class also, and let me finish it. Okay, now in this, let's define the separate function called selection sort, and let's implement the same thing in that specific function. So the declaration of the function will be public static. In the end, we will have to return the sorted array, and let's name the function name as selection sort, and it will take a variable of type array in the variable arr. Okay, as part of the pseudocode that we have written, what we have done, we have to find the appropriate value for each and every index or each and every position in the array, right? For that, we have written a for loop. So in the beginning, for int I equal to 0, I less than array dot length and I plus plus, and internally, if you remember here, we have used a variable to hold the smallest values position in the remaining array. Okay, let's name that as int current index. Okay, let's assign it with the value of I only. Okay, because when we start comparing for that specific position, right, whatever the element that we are starting with, it itself is the applicable value. So I'm assigning the current index with the value I itself. Later on, what we exactly did, we compared the value at this current index with the remaining values in that array. For that, what we have to do, we will have to run a loop for int j equal to it. Remember it. So in the array, we will have the sorted values as well as we have the unsorted values, right? We will have to compare only with the unsorted half or unsorted values, right? For that, obviously, we will have to start comparing with the unsorted values, means that index will always be from I plus 1th position, okay? And it will always be less than length of the array, and in each and every step, sorry, it is j. In here, now what we will do, we will compare the value at the current index and the value at the jth index. Okay, at any case, if the value at jth index is smaller than the value at the current index, that means the value at the jth index is smaller. So we will have to update the current index value with the index j. So that's what we will do now. If array of current index is greater than array of j, then what we will do, we will simply be updating current index equal to j. Okay, here we have named the array as arr. Okay, by the time we complete this internal for loop, we will have the applicable appropriate values position inside this current index. So what we have to do, we have to swap the values of ith index and current index value. For that, what I will do, let me define a temporary variable. Let me assign it with the value of arr of current index. Now the current index value, we will update it with the value at ith index. In the end, array of ith index will get assigned with temporary value. Okay, what we did, we ran an internal for loop from I plus 1th index to find the appropriate values position in the unsorted part of the array. Okay, once we complete that, we have that position in current index variable, and now we have to fill that value into the ith position. Okay, for that, we should not lose ith value for the further sorting, right? That's why we are simply swapping those two values. Okay, if you see the implementation here, in case of bubble sorting, we compared two adjacent elements for all the elements, right? And if they are not in the appropriate order, we basically swapped them. But if you see here, we are simply comparing, but we are not swapping. We are swapping only once here. Okay, so if we repeat the same logic for n number of times, if there are n number of values, we will have the sorted array inside the variable ARR itself. Okay, selection sorting algorithm is also one of the in-place sorting algorithm only. So in the end, we will simply return ARR directly. Okay, I hope it is clear to you. Now let's go ahead and let's try running the same application. Okay, let's assume that the unsorted array is A and it has values 1, 2, minus 10, 11, 30, 11. Let's say it is minus 11 and 12. Okay, now we will have to call this function, right? This function is selection sort and it will accept integer array A. Okay, in the end it will return the sorted array, right? So let's take that sorted array into the variable sorted array equal to selection sort of this one. Let's try printing it. Int I equal to 0, I less than sorted array dot length I plus plus. Okay, system dot system dot out dot println of sorted array of I. Okay, so if we execute this program, we should get minus 11, minus 10, 1, 2 and 12 because we are trying to sort the values in the ascending order. Okay, do you see? It is same. Okay, even if you run the same application for one input, or if the array has 100 numbers of values also, you should see the resulting array that contains the values in the ascending order. Okay, similarly, if we have to write the same application or same program for descending order, what we will do, we will simply copy the program. Let's say the function is, let's modify the function name as descending order. Okay, here whatever the comparison that we are doing, if we will modify it to less than, we will have the values of array in the descending order. Let me just call this function and let me just show it to you. Okay, do you see 12, 2, 1, minus 10 and 11. Okay, this is how the selection sorting algorithm is actually implemented for ascending as well as descending orders using Java. Okay, thanks for watching. I'll see you in the next one.